We're going to start by recalling some of our interval notation or set notation. So what we've got here is interval notation. This means from -2 to 3, with 3 and 2 included because of these square brackets. So if I'm going to draw this, I need to go from -2 to 3. If it's included, we used a closed circle and we just join up like so. So a closed circle means is included, and we do it like that. And an open circle is not included, and we do it like that. So this next one from -3 to 4, we could write that as -3 less than x less than or equal to 4. So if I'm going to draw that one, I'm going to go from -3 up to 4, not included, is included, join it up. Then for C, from -infinity to 5, or 5 is included, I'm going to put it here, -infinity up to that. So it's anything down this way, all the way to -infinity up to 5. And the last one from -2 to 4, and these are open circles because neither -2 nor 4 is included. So you can go ahead and do those questions in 1A now if you like, but I'm going to keep talking. So let's have a look. We're going to look at what an ordered pair is, and an ordered pair is just a set, two numbers, x coordinate, y coordinate, and a relation is a set of ordered pairs. So it could be something like the set of 1, 1, 1, 2, 3, 8, etc. Our domain, we know from units 1 and 2, is all the x values, and the range is all the y values. So if we have something like this one over here, y equals x squared, let's see what it looks like. It's a parabola with a centre at 0, 0, so it looks something like that. This one has a domain, which is all the x values. So x can be anything, so I'm going to say R, and it has a range. Well, you see the range is only these positive values here. So the range we could say is from 0 to infinity with 0 included. Let's see, can we remember what a graph of square root x looks like? Hopefully, graph of square root x looks like this. So what we find there is the domain is 0 to infinity. I could also write that is all the positive numbers and 0. Either of those is okay, no real preference. And the range for this one, again, it's just the positive numbers, just like for x. So we could write 0 to infinity, or we could write r plus and 0. So domain and range. So we're going to sketch some graphs here. So actually, we're not, because we just did this one up top. We just did a y equals x squared. Just did it there. We're not going to do it again. Sorry about that. So let's look just at C. We're going to put these ordered pairs. So I'm going to go -2, -1, -1, -1, -1, 1, 0, 1. So it's going to look something like that for that set of ordered pairs. So the domain is all the x values, which are -2, -1, and 1. We won't put this twice. Actually, I've forgotten 0, haven't I? So -2, -1, 1, and 0. And this is actually a set of numbers. It's not a coordinate. So it looks like that. And what is our range? Well, our range, we've only got two values, two y values, and they are at 1 and at -1. So it's just the set of those two. So it's a little bit different when we've got just a set of points as opposed to something that we looked at where really if we look at x squared, there's an infinite amount of points that we're joining up together to get that curve. So that's why its range and domain are continuous. All right, so what are we having a look? What is a function? What is not a function? So relations are like everything. Everything is a relation. But is it a function? How do we know if it's a function? A function is a relation such that for each x value, there is only one y value. So that's how we know whether something is a function or not. For each x value, there is only one y value. So let's look at this first one. For each x value, there's only one y value. That's true. So yes, it is a function. But let's look at b. For every x value, so here we are, when x is -4, sometimes it's 1, sometimes it's -1. So that does not have only one y value. So we say, no, not a function. So in terms of thinking it as graphs, let's draw up some axes. If we have something like a parabola, it's always a good example, isn't it, the parabola? Is it a function? For every x value, is there only one y value? Yeah, there is. But how do I know that? Because we do what we call a horizontal line test. Sorry, no we don't. We do what we call get out your liquid paper, a vertical line test. And so we pop a vertical line through, and if it only touches once, then yes, it is a function. So this one is a big fat yes. But if we had something like, I'm going to do a circle. And we don't necessarily do circles in the course, but it's a good example. So if I do a horizontal line test, a vertical line test here, I've got to stop saying that. See how it touches twice? So that one, no, it's not a function. So to see whether it's a function, I say we do the vertical line test. No, that's not a typo. It's actually an F, because if it's a function, we use F for vertical, and we'll see why later on. All right, let's keep going. Identifying, describe, okay, we're doing the same thing. Find g of -2. Again, it's something we've done this year, just revision. So what it's saying, if g of x has an x, then g of -2, everywhere we see x, we'll write -2. So this becomes g of -2 is 3 times -2 squared plus 1, which is 3 times 4, which is 12, plus 1, 13. If we want to find g of 4, every time we see x, this time we write 4. 3 times 4 squared plus 1, which is 3 times 16 plus 1, which is 49. So it's just replacing that x value with whatever we've got in the brackets there. So let's do the same thing here. What's g of -2x? Well, we go 3 times -2x squared plus 1, which is 3 times 4x squared plus 1, which is 12x squared plus 1. If we do the next one, g of x -2, we're going to replace the x squared, so it's 3 times x -2 squared plus 1. So we expand these brackets. And we go about it for the same way for these. Actually, I'm going to take those off. I'm not going to bother doing those because it's the same thing. And then we'll just take a break there and come back with the second half of 1B in a minute.